All right, find the limit if it exists. So for our three examples, we have the limit as x approaches infinity or negative infinity. I want to show you a technique we can use to analytically show our work. So the limit as x approaches infinity. What we're going to do is divide every term by the highest x variable in the denominator. So when I say highest, I really mean the x variable in the denominator with the greatest power. For the first example, it's just x. So this means I'm going to divide every term by x. So x over x minus 6 over x, 8x over x, plus 2 divided by x. Remember, when we consider limits as x goes to infinity or negative infinity, we're asking the question whether or not the function approaches some horizontal asymptote. So if you remember your algebra techniques, you know the horizontal asymptote is 1/8. But let's see if we can show analytically that the limit that the function will approach is also 1/8. So now let's clean this up. X over x, of course, is 1. 6 over x, well, as x goes to infinity, this will be 6 divided by a very big number, which means this will go to 0. 8x over x, well, again, that's 8. And then 2 over x. Again, as x goes to infinity, 2 divided by some really big number will go off to 0. So our final answer is 1/8. So again, you can see it by thinking about the horizontal asymptote. When the degree of the numerator and the degree of the denominator are equal, the horizontal asymptote is the ratio of their coefficients, but that also represents the limit as x approaches infinity. I like to use this technique because then we can analytically show that it is 1/8. All right, so using the same technique, let's try the second and third examples. Okay, so what is the highest x in the denominator this time? X to the 7th power. So I'm going to divide everything by x to the 7th power. And then we'll clean it up. This will become 2 over x to the 5th power minus 2 over x to the 7th power all over 1 plus 8 over x to the 6th power minus 3 over x to the 7th power. Now as x goes off to infinity, this expression goes off to 0 because 2 divided by, x goes off to negative infinity. This still goes to 0 because it's 2 divided by a negative big number. Okay, so it's the fact that it's a big number, so it goes off to 0. This is being divided again by a big number, a negative big number, but it still goes off to 0. Of course, if I didn't have 0 completely in the numerator and I had some value, some actual number, I would have to have a conversation about what happens to this minus sign. But because I have just 0, I can bypass talking about that. In the denominator, I have a 1. That's good. Well, 8 divided by x to the 6th power, as x goes to negative infinity, this is 8 divided by some very big number, which goes to 0. This is 3 divided by, again, some negative big number, which also will go to 0. So we end up with 0 over 1, which is 0. Now, of course, if you remember your algebra topics, when the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is 0. But analytically, we want to show it to be 0. All right, one more. I like this kind of problem because there's a square root in it, and the square root forces you to really think about it. Be clever. All right, so what is the highest x in the denominator this time? X to the second power. So let me just go ahead and divide everybody by x to the second power in my denominator. Now, unfortunately, in my numerator, I have a big square root. And you might be tempted to divide everybody by x squared inside the square root. But we know we shouldn't do that. Hopefully you know you shouldn't do that. Let me write it off to the side. The square root of x to some power gives you x squared. What would be the power? 4. The square root of x to the fourth power will give you x to the second. So what should you divide everybody by down here? X to the fourth. This is why I like this kind of problem, because if you're not paying attention, you'll just divide everything by x squared and ignore the square root, because the square root of x squared is just x. So be careful. All right, so now let's clean this up a little bit. All right, now let's have that nice discussion about what happens to the expressions as x goes to infinity. Well, 4 divided by some big number will go off to 0. 1 divided by some big number will go off to 0. Of course, 3 is good. 5 divided by some big number will go off to 0. And we'll end up with 0 over 3, which is 0. So again, this video is just to show you the technique of analytically showing what the limit approaches as x approaches infinity or negative infinity. Again, there's many algebra topics that you can use to achieve your answer. However, if you want to just focus on the calculus, then this is a nice technique. Hopefully this has been helpful.